type of set, operation on sets. So start chapter first. Sets. What is sets? A well-defined collection of object is called a set. Okay, a well-defined collection of object is called a sets. Well-defined, what do you mean by well-defined? Well-defined. Here well-defined mean set of object having same property. Having same property. Okay. Sets are usually denoted by capital letters by A, B, X and Y, etc. and their elements by small letters like small a, small b, x and y, etc. If some element belongs to a set n, let n is any set, then we used the following symbol as x belongs to n. X belongs to n. If x not belongs to n, then it is this symbol read as x not belongs to n. That means x is not in the set n. Okay. Okay, now we come to the next definition. Representation of sets. Representation of sets. Sets can be represented in two ways. The first form is a roster form. Roster form, it is also known as a listing method or tabulation method. Okay, in this method the element of sets are listed and they are represented by commas and enclosed by curly bracket as n is equal to set of natural numbers. As n is a set of natural number, then it can be represented as n is equal to curly bracket 1, 2, 3, 4 dot 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 dot. Okay? So in this way we can represent the set. This method of representation is known as roster form, tabulation form or listing method. Okay? Because in this method we are separating the element by commas and listing each and every element of the set. Okay, now come to the next topic. Second method to represent the set is rule method. It is also known as set builder form. In this method, the element of sets are represented by some common property or by some rule as x, suppose S is any set, then this is equal to x. These two dots are known read as such that, and px where px is some property. Okay, for example n is equal to set of natural number. This is the previous one example, set of natural number. Then in rule method or builder form, this can be write as x such that. These two dots are known as such that what is the property of x? X is a natural number. Okay, so this is representation is in rule method or set builder method. In this method we represent the set by the common property. So what is the property of x? The property of x is a natural number. So this representation is known as the set builder form or rule method. Let's take an example. Question number 1. If a is equal to 1, 2, 3, 4, 5, this form is known as the roster form. Okay, and then write a in rule method or it is also said to be set builder form. So represent this set in set builder form. Solution, simply देखो a is equal to 1, 2, 3, 4, 5. So a is equal to curly bracket x, two dots read as such that. So x such that, what is the property of x? X is a natural number natural number from 1 to 5. So we can write this x less than equal to 5, x greater than equal to 1. That is greater than equal to 1 में 1 include the set. Similarly, x less than equal to 5, 5 is included in the set. And what is x? X belongs to n. ठीक है. So this representation is in rule method. Okay, let's take another example. Example number 2. Example number 2. Write the set, write in set builder form if b is equal to 1, 1 upon 3, 1 upon 9, 1 upon 27 dot dot dot. Solution. Here b, look carefully, this is 1, this is 1 upon 3, 1 upon 3, this is 1 upon 9, 1 upon 9 can be write as 1 upon 3 की power 2, this is 1 upon 27, 1 upon 27 can be write as 1 upon 3 की power 3, that is 27. So we see that this series can be write as 1 upon 3 की power 0, because 1 can be write as 3, 1 upon 3 की power 0. Similarly 1 upon 3 can be write as 1 upon 3 की power 1, 1 upon 9 can be write as 1 upon 9 can be write as 1 upon 3 की power 2. Similarly 1 upon 27 can be write as 1 upon 3 की power 3. Okay, so we can represent b is equal to 1 upon 3 की power n such that n belongs to positive integers. ठीक है, और we can write x is equal to 1 upon 3 की power n such that n belongs to I plus, where I plus set of positive integers. Okay, so set can be represented by two ways. The first is roster form or raster form, and the second is set builder form. ठीक है, in first method we can list the element, and in second method we write the set by the property of the set, for as example 1 and as in example number 2. Okay, so now we start topic number 3rd. This is topic number 3rd, type of sets. Type of sets. So start topic 3, type of sets. In this topic we mainly discuss the definition of sets. The first definition is finite set. Simple finite. What do you mean by finite? If the number of element is finite, then it is said to be a finite set. So similarly this words include in definition, a set is said to be finite if there are finite number of elements. For example, a is equal to curly brackets 2, 4, 5, 6, 7. So number of elements, how many numbers of elements are there? 1, 2, 3, 4, 5. So they are finite number of elements, so this is called finite. Similarly we have infinite set. Infinite means we are unable to count the numbers. So what will be the definition of infinite set? A set is said to be infinite if there exist infinite number of elements. For example, set of natural number n is equal to 1, 2, 3, 4 dot dot infinity. Number 2, set of real numbers. We are unable to count the real numbers. Between two numbers 1 and 2 there exist infinitely many real numbers. C for rational numbers lie between 2 and 3. For example, not C, rational numbers lie between 2 and 3. As we know, between two numbers there exist infinitely many rational numbers. Okay, so this is a definition of infinite set. Now come to third definition, null set. It is also known as empty set, or it is also known as void set. Null set, empty set, void set. We generally use empty set. So empty set means a set having no element is called null set or void set. It is denoted by phi, F-I-E, phi. This is denoted by phi. Write as this is phi. Okay. So remember, the main thing in the definition is the notation. So we denote empty set by phi. So main thing is phi. Notation is phi. ठीक है. Okay, let's take the example. Example number 1. Let a is equal to curly brackets set of natural number lie between 2 and 3. Set of natural number lie between 2 and 3. Yes. As we know, there exists no number lie between 2 and 3. So the value of a is 5, there exists no element. So this is A is the empty set. Similarly, let B is equal to x such that x belongs to R. ध्यान रखिए, x belongs to R and एक्स स्क्वायर प्लस 1 इज इक्वल टू 0. ठीक है, सो b इज इक्वल टू क्या, x की वैल्यूज हैं. b के अंदर किस टाइप के एलिमेंट्स आ रहे हैं, b के अंदर x टाइप के एलिमेंट आ रहे हैं और वो x कैसा होना चाहिए, x शुड बी ए रियल नंबर. ठीक है, एंड फ्रॉम वेयर x कम फ्रॉम द इक्वेशन एक्स स्क्वायर प्लस 1. दैट मीन्स solution of x square plus 1 which are real number come to the in set B. Okay, so let's find the answer. Here we see x square plus 1 is equal to 0. So simplifying we get x is equal to plus minus I, because the under root of minus 1 is complex number I plus minus. ठीक है, so but plus minus is not a real number, so we see that here the set B is a empty set because there exists no value of x which is a real number. So here B is a empty set. Okay, now definition number 4, singleton set. Singleton, single का मतलब एक. The set having only one element is called a singleton set. There are many examples. A is equal to 1, A is equal to 0. This is x is equal to 5. In x there is a single set 5. This is also example of singleton set. Next definition number 4, subset, superset, proper set. Okay, so don't confuse subset, superset, proper subset. So if A and B are two sets, and every element of A is in B, if every element of A is in B, then A is said to be subset of B. ध्यान दें, let A and B are two sets and every element of A is in B. Every element of A is in B, then A is said to be subset of B. Write as A subset of B. Look there, if x belongs to A, that is, and A subset of B is that is mathematically it can be write as x belongs to A. X belongs to A implies x belongs to B. ठीक है, okay, don't read this, don't worry. So that is here A is said to be subset and B is said to be superset, and notation is, remember the notation, this is the notation of subset. So this is A and this is B, so A is called subset and B is called superset. ठीक है, now come to the proper subset. What is proper subset? Proper subset. So if A is not equal to B, then A is said to be proper subset of B. A is said to be proper subset of B. Write as A proper subset of B. In this case we do not apply the is equal to sign and this is A subset of B. So here A is said to be superset of B. Okay, so we can see this is A superset of B. Okay, come to the next topic. Next is equal set. Two set A and B are said to be equal if they have same element. If they have same element, simple. Equal means equal, everything is equal. That means if they have same elements, then they are said to be equal. And write as A is equal to B. So equal set A is equal to B, or the definition of equal set can be defined as two set are said to be equal if A subset of B and B subset of A. That is, all element of A are in B and all element of B are in A. ठीक है, तो mathematically the definition of equal set can be write as A subset of B and B subset of B, then two sets are said to be equal. A is equal to B. ठीक है. So A is equal to B if and only if A subset of B and B subset of A. That is A is equal to B. This is a symbol of by condition. From both sides this is true. If A is equal to B, then we have A subset of B and B subset of A. And conversely, if we have A subset of B and B subset of A, then we have A is equal to B. Okay. For example, A is equal to 1 2 3 4 and B is equal to X, such that the value of X lie between 1 to 4 and X belongs to N. Then clearly what is the value of B? What is value of B? What is value of B? The value of X is lie between 1 to 4. So the value of X is 1 2 3 and 4, because 1 2 3 4 is the numbers which is equal to 1 and less than equal to 4 and natural numbers. So we see A is equal to B. Okay. So now come to the next definition, universal set. What is universal set? यूनिवर्सल सेट एक ऐसा सेट होता है जो हर एक सेट का सबसेट होता है. सबसे बड़ा सेट इज सेट टू बी ए यूनिवर्सल सेट. लेट्स रीड द डेफिनेशन. ए सेट विच इज proper subset of all sets is called universal set, is denoted by U. The main thing is U, notation is U. So universal set is denoted by U. ठीक है. तो एक ऐसा सेट होता है जो सब सेट का proper subset होता है. That means all set contain in this set. This is called a universal set. Okay. So ये आपका universal set हो गया. For example, let A is equal to set of vowels A, E, I, O, U. That this is set A. Then U is equal to क्या होगा? That is U means universal set. U is equal to set of all alphabets is the universal set for A. Okay. So here the problem set 1.1. There are some questions. Question number 1. Describe each of the following sets in roster form. We have to convert in roster form, that is we have to listed all the elements. Okay, ये भी exercise का ही part है. This is question number 4th. Question number 5. Question number 2 है describe the following sets in set builder form. Question number A 2 4 6 8 second third fourth fifth. These in all question number 2 we have to write in set builder form, यानी कि rule method, rule बना के लिखना है. In question number 1 we see that 2 4 6 8 even integers. Let's try yourself. अगर नहीं आता तो मुझसे आप पूछ सकते हैं. Okay. Similarly question number 3 है list the subset of the set 0 1 2 3. B list the subset of this. Okay, question number 3 में we have to write subsets. Okay, एक क्वेश्चंस देख लेते हैं. क्वेश्चन नंबर 3 list the subset of the set 0 1 2. Then second part is list the subset of the sets phi I A B. Okay, we solve the first question. This is any set 0 1 2 3 and we have to find the subsets. Subsets means how many subsets we can make. So this is first is phi empty set. This is subset of all sets. Secondly, we can take 0 and make the set. Second is 1 and make the set. Second 2, make the set. Similarly, take the pairs of two elements 0 1 0 2 1 2, and the last is whole set, because whole set is a subset of itself. So this is 0 1 2 and 3. ठीक है. And that is number of subset will be 2 की power, and this is the formula to find the number of subsets to 2 raised to the power n, where n is the number of element in a set. How many elements are there? There are 3 elements 0 1 2 3. So 2 की power 3 is equal to 8, where n is the number of elements in a set. Now we come to the next topic, and this is main topic of the set theory, operation on sets. The first definition is union of set. Let A and B are two sets, then union of A and B is the set of those elements which are either in A or in B or in both A and B, denoted by A union B. That is, A union B is equal to X such that X belongs to A or X belongs to B. ठीक है, that is A union B is the set of those elements which are in A or in B or in both A and B. Okay, ये read this line carefully. So A union B is equal to X such that X belongs to A or X belongs to B. If X is equal to this, X belongs to A union B, this implies X belongs to A or X belongs to B. Or if we are saying X not belongs to A union B, then this implies X not belongs to A and X not belongs to B. Write this. In one place is or and the other place is and. Okay, this is the important point. Let's take the example number 1. Let A is equal to A, B, C, D. B is equal to A, E, I, O. Then we have to find A union B. A union B. What is the definition of A union B? A union B is the set of those elements which are in A or in B or in both A and B. We see that A is here, A is here. So A will be here. Similarly, B is here, but B is not here, but B will be here. Similarly, C is here, C is not here, so C is there. D is here, D is not here, D will be there. Similarly, E, I, O, U. So we see that all elements A, B, C, D, E, I, O, U are in A union B. Is the set of those elements which are in A but not in B. Okay. Next definition is intersection of sets. Let A and B are two sets, then intersection of two set is a set of those elements which are common in both A and B, and the intersection of two set denoted by A intersection B. So A intersection B is equal to set of elements which are common. That is, mathematically it can be write as A intersection B is equal to X such that X belongs to A and X belongs to B. Note this, in intersection we use and in union we use or. Okay. So intersection A intersection B is equal to curly bracket X such that X belongs to A and X belongs to B. And if X belongs to A intersection B, that is X is any element, then this implies X belongs to A and X belongs to B. If we are saying X not belongs to intersection B, then this implies X not belongs to A or X not belongs to B. Listen carefully. If X belongs to intersection, then we use and. If X not belongs to intersection, then we use or. Okay. We can take an example. If A is equal to A, B, C, D and B is equal to this, then A intersection B. A intersection B, which are common in both A and B. So A. So in both set A element is common. Okay. So A intersection B is equal to A. Okay. Next definition is complement of sets. Complement of sets. Let U is the universal set. Then complement of a set A denoted by A dash. This is A dash. A dash is a set of those elements which are in U, not in A. Listen carefully. Set of those elements which are in U but not in A. That is, A dash is equal to U minus A. The complement of a set can be denoted by A to the power C also. Okay? That is A dash. A dash is equal to set element in U but not in A. Okay, so mathematically it can be write as A dash is equal to curly bracket X such that X not belongs to A. That is A dash is the set of those elements which are not in A. If we are saying X belongs to A dash, this implies X belongs to U minus A, because A dash is equal to U minus A. And if we are saying X belongs to U, and this implies X belongs to U and X not belongs to A. Okay. So x belongs to a, this is ये हो गया, the complete हो गया, the complete हो गया, x not belongs to a. Let us take an example let u is equal to 1 to 10, a is equal to this, then by the definition a dash is equal to u minus a, that is write u, this is a, that is we have to find a dash, so this is a dash. 4 cancel out 4, 5 cancel out 5, 6 6 cancel हटा दो, 7 7 हटा दो. That means we have to remove element of a from u, that is element of a are 4 5 6 7, तो 4 5 6 7 और यहाँ से 4 5 6 7 रिमूव कर दो. So we have 1 2 3 8 9 10. So we see here this is the value of a dash, and as we see in definition, the a dash is the set of those elements which are not in a. Or what is in a? A is 4 5 6 7. We see that neither 4 is here, neither 5, neither 6, neither 7. ठीक है. So a dash is the set of those elements which are not in a. Okay, this is a dash. Now we come next most important definition, difference of set. Okay, let a and b are the two sets. So difference of set, let a and b are two sets, and difference of two sets denoted by a minus b. A minus b, and a minus b is the set of those elements which are in a but not in b. Mathematically it can be write as a minus b is equal to elements in a but not in b. ठीक है. Or it can be write as in set form a minus b is equal to x such that x belongs to a and x not belongs to b. X not belongs to b. ठीक है. So if we are saying x belongs to a minus b, this implies x belongs to a and x not belongs to b. Let us take an example. Example number 4. Example number 4, that u is equal to this, a is equal to this, and b is equal to this. Then a minus b, that is value of a, it is value of b. So a minus b, that means we have to remove the element of b from a. So this is 4 5, 4 5 is common, so remove 4 and 5. So remove 4 and 5. So a, in set a we have 6 7, so the value of a minus b is equal to 6 7. Similarly, if we have to find b minus a, so this time we have to subtract b from b from we have to subtract b and a, this is b and a. So the common element is 4 5, again the common element is 4 5, so remove 4 5, so 4 and 5 is removed, so we have 2 3. Okay, so this is 2 3. Okay, we can see this is 2 3. Okay, now come to the similarly there is a another definition. This is known as the symmetric difference a delta b. The notation between a and b is not as uh, read as a delta b. A delta b is equal to a minus b union b minus a. So what is a minus b is 6 7, what is b minus a is 2 3, and the union of these two set is 2 3 6 7. Okay, this is 2 3. And last definition is disjoint set. Disjoint नेम से क्लियर है, disjoint का मतलब अलग अलग. That is two sets a and b are said to be disjoint if they have different element, or mathematically we can write disjoint set if a intersection b is empty. So if a intersection b is empty, then two sets are said to be disjoint. So here we have exercise number 1.2. This is exercise number 1.2. So once we see all the pages and full page, so this is our last page, this is first page, disjoint of sets, this is this one, 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 this one. Okay, you can take a screenshot, or I provide you